Now I'd like to introduce Jeremy Schulman, who will be presenting Design-Driven Network Assurance. Jeremy is the Senior Director of Solutions Engineering at Major League Baseball, is coming to us today from Raleigh, North Carolina. It's Jeremy's third time presenting at NANOG. Jeremy's first talk at NANOG was called Is the Network Ready for Use at NANOG 77 in Austin back in 2019. Welcome back to NANOG, Jeremy. It's a pleasure to have you back with us today.
Good morning. Can everybody hear me okay? Awesome. So first I'd love to thank the program committee for allowing me to give this presentation and for all of you to joining. This presentation is about 10 years in the making for me. So it's really the culmination of my network automation journey and where we are in how we go about doing network automation and infrastructure as code. So I wanted to share with you our approach, which I think is something you have never seen before, and I hope you're very excited to see it. I'm super excited to show it to you and get your feedback on it. I'd like to thank Chris for that awesome presentation. Before we get really started, I wanted to ask, kind of show of hands, how many of you are involved in network automation yourselves? Okay, so that is a great show of hands. Like, I asked that same question 3 years ago or so, and it was maybe 20%. And how many of you are involved in like building technology, like you're actually involved in creating that automation system, like you're writing Ansible playbooks or you're writing Python code, or you might identify as a network automation engineer, even though that might not be your job title. All right, so it's a good show of hands. I want to set the context of my 10-year journey. About 10 years ago, I was working at Juniper Networks, and I was kind of a consulting engineer, helped the field, and an account manager. Oh, I got to stand next to the mic. I don't have a thing, sorry. I tend to walk around. And an account manager said, hey, we've got this huge deal and we need you to come in and talk about network automation because it's very important to this customer. And I went in there and the SE talked about speeds and feeds of the box, and the SE talked about Junos as an automation capable operating system. And then I listened to what the customer really wanted, and they said, we don't care about your box. We don't care about the speeds and feeds. We don't even care about Junos as an operating system. Yeah, it's great. But what we care about is having Puppet on your switch so that the server team, the application team, can roll out their application and roll the network changes that they need for it using the same tool. And I was like, okay, that's cool, that's cool. And so we left. And I turned to my buddies, I'm like, what's Puppet? Right? I had no idea what Puppet was. And so, but I found out what it was. And at the time, this is back in 2012 now. This is back before there was the word DevOps. This was back before there was the word infrastructure as code. And so it turns out that, as it would happen, there was another Jeremy working at Juniper, and he knew Puppet because we happened to use Puppet for our server stuff. So we collaborated, and we did this thing, and I learned what Puppet was. And how many of you know or heard of Puppet and Chef and Ansible? Okay, that's awesome. All right, so contextually, they were a company, and much like Chef and Puppet and Ansible and Salt, they were taking a new approach to a problem that the server admins had struggled with, deploying fleets of servers consistently, et cetera, et cetera. And they had this paradigm shift of how to do it differently. Rather than writing bash scripts, and Bob had his collection of bash scripts, they're like, this is terrible, what if Bob quits, right? Have you heard this now? It's like, well, we're building all these network automation scripts. Well, what if Bob quits, right? It's the same story. And I had this kind of realization then back in 2012 that the movement or this transformational technology that the server administration people were using was going to roll right into networking. It wasn't, I would say, obvious, but people in that DevOps world started approaching me because once I showed that we did Puppet on a switch, not that that was like a big successful thing, but we did it. They're like, wow, the networking community is looking at adopting these ideas. And they took me aside and they said, here's all the things that we went through. This is what the next 10 years of your life is going to look like. And in many ways, they were right. And so I spent about 6 years at Juniper and other startups maniacally focused in network automation. That's all I did. Like I literally changed my career in 2012 and said, all I'm going to do is focus on network automation and essentially try to bring what I like to refer to as Iron Man suit technology to the network engineering community. All right, you guys know Iron Man, Marvel, you know what I mean by Iron Man suit? It's like this, gives you a superhuman capability, but there's still a human operating it, not to use technology to replace network engineers. I think that's a ridiculous notion, and history shows us time and time again that doesn't really happen. So I had to come up with a slide title here for what I wanted to try to encapsulate as this idea, and I called it Design-Driven Network Assurance. And I had some other titles like, what if we're doing it wrong? Or, you know, like, what if vendors are giving us really bad advice? But the program committee said that was probably a bad idea. So what I'm hoping that you take away from this is I believe I'm gonna show you something you've never seen before, right? Now, it's an amalgamation of a lot of different concepts from a lot of different industries and my software engineering background and such. But I don't think anybody has shown this approach before. So I hope it blows your mind. I hope it shatters your concepts of what you think we should be doing with network automation or how we even approach it. And I'm not saying, I wouldn't say that what I'm going to show you is the transformational paradigm shift that the network industry desperately needs. I mean, I wouldn't say that. When you fill out the survey today, you might say that. That would be great. But so I'm going to take you through what is really a deck of concepts. I'm not trying to sell you a tool. I'm not trying to build anything other than awareness in your mind of another idea, another approach to taking when you're looking at your network automation projects. All right, let's get to my background. Like, most of you are service providers, but in my world, I work for Major League Baseball, and we have what I think is one of the most interesting networks to deal with. We have to deal with multiple vendors. I've got some legacy stuff out there that is not very automation friendly. We have multiple, if not almost all the networking domains. We have, WAN, we have data center, we have campus, we have Wi-Fi, we have high density Wi-Fi. Every ballpark kind of operates as its own mini data center. It's fascinating technology that we have at the ballparks that offer a very complex edge of our network. We have a lot of audio-visual equipment that has very specific precision time protocol requirements, multicast requirements. So as an automation engineer junkie, I'm like, wow, I get to do everything. Like, there is not like just trying to solve data center. Now, we're not scale, we're not like a data center that has the same problems like Google has, for example, right? So they have maybe, or a mega scaler, they might have a different kind of problem domain that they're trying to solve. But this is my problem domain. And we have brownfield situations, where we're adding features or functionality or new deployments. We have greenfield. And I think what also makes it really hard for us is that we have to deal with, in the field, there are smart hands that sometimes get things terribly wrong. They plug something in wrong. They have the wrong transceiver type. There's a lot of complex problems that really don't have anything to do with necessarily the network engineer itself. It's just a really hard problem, and we have to be very agile in dealing with changes in the field in the moment. And that's kind of before we go live into the season, right? So that's just a little kind of my background. So when I look at this problem, the problem to me, the hardest problem to solve in network automation, and kind of if you think about it, what the users or the stakeholders of the network want to know is the network okay? Is the network operating as we expect it? Is it a quality network that we can rely on? Now, I'm using the term network quality assurance here in the same way a software engineer would use the term software quality assurance. Now, are folks familiar with like what SQA is or what that even means? Okay, so basically, think about it this way. If I was a software engineer and I write code, I have to write unit tests to prove that my code is not broken. And then that code gets to the next group where they do, say, integration or functional testing, kind of black box, right? So they do this process in order to make sure that the quality of the software is good before they ship it to production. So we talk about this concept, infrastructure as code, but this is a concept that I've started with, or my point of view starts with, what if we looked at the network automation as assuring the quality of the network by taking the same approach? And so the idea is that we want to ensure the network is operating as expected with as much context as possible, maximizing situational awareness. And what I mean by that is, if something is wrong, that I can go from, oh crap, to all clear super fast, right? That sure, configuration management is a problem and an opportunity for automation, and that's almost exclusively what vendors talk about, or the topics that you hear is config management. This is kind of tilting the whole script on its head. And so our approach is to start with the design. You saw in Chris's presentation that design was at the very bottom, and I think a gentleman asked, like, well, what about if we started with the design as a function of automation? We start with a design. Now, I'm going to talk about what a design means and how it works in this kind of architecture. But from that design, our system, this approach would automatically generate the checks that we can apply to the network. In the same way that if I was a software engineer, it would look at my requirements and automatically build the unit tests and the functional tests. And that's like a pipe dream for software engineering, right? But what if we could do that in networking? And I believe we can. I mean, not only do I believe we can, we've built a tool that allows me to demonstrate this idea. But this presentation is not about that tool. This presentation is about the ideas behind it. Now, what's important is that when change happens, like a change to the network, like we need to make a change, we start with putting that change into the design, and then we kind of compile that design. And so when change happens, we have this essentially this is our source of truth, and so that we can then validate the changes as they happen operationally, right? So again, if you're a software engineer and you're compiling code and testing code and you go through that process, this is kind of a similar idea. So that's kind of like the big idea here. So this is just a quick, very small demo of the tool that we built. And what I'm really just trying to show you here is that it's possible to take a design and from it generate a bunch of checks and then run those checks very quickly and to get operational results. And what you're kind of seeing here is this is in real time. It is one of our sites that only has maybe like 4 devices. I can within 10 seconds know operationally is this network okay? And if it isn't, drill into exactly what the problem looks like, okay? And if we change the design, we get more checks or different checks. And I took the same technique and ran it against all of our minor league ballparks all at once, which amounted to be about 9,000 checks. And we can complete 9,000 checks in under a minute. So I'm telling you that this kind of idea is possible. It's not something maybe you've ever seen before, but it is absolutely possible to do this. And people like to talk about source of truth. Like it's kind of one of those triggering conversations for me. It's like, what is the source of truth? Everybody wants to talk about source of truth. But really, the current operating state of the network is a source of truth. You must accept this because it is true. This is your network. This is what it's doing, right? And we look at a design as another source of truth. And when we look at a design, the goal is not necessarily to encompass every operational aspect of our network. We're going after an 80-20 rule, just like a software engineer might not be able to do 100% code coverage. But the important pieces that drive our business, we want to make sure are operationally correct. Now, we look at the difference between the operationally running state of the network, that source of truth, and our design, and we compare these two truths to identify anomalies. Now, an anomaly is not a configuration error. I mean, it could be, but that is not necessarily what it is. It could be that something's broken, like a transceiver broke. It could be that somebody cabled something into the wrong place. But it's important to realize that as we approach network automation, that it isn't just about configuration management, which is kind of another triggering topic for me. So I'm going to call that out, right? What about configuration management? Configuration management is not a source of truth. And the way I look at it is that a configuration affects the state of your network. You want the network to do a thing, you make some configuration, it makes that you believe that that configuration will achieve the outcome you want. But it's an affect. It's a byproduct of the design, right? And in my world, I have to work in a real world environment where there are going to be times when humans make changes to the network. They, for whatever reason, they get on the CLI, they make a change. I can't tell you how many vendors, and even maybe when I was at Juniper, say like, oh, if you automate everything, it's going to be great, and the network engineers like, the CLI, my cold dead hand, like that is a real thing, and we have to acknowledge that, right? At least I do. And then we also have to acknowledge that changes, when we want to automate changes to the network, we want to have choice and control over the tools that we use. Maybe we use Ansible for some things. Maybe we use a bespoke Python script. Maybe we use this system that I'm describing. But those two actions, validating the operational state and configuration management, are decoupled. And that is an important concept to keep in mind. So I'm going to kind of go into what do I really mean by a design, because that seems very, kind of esoteric in your mind. And one of the things that I really want to do is make these ideas as concrete as possible without like getting so deep in the weeds of showing code. So there's no code here. If you've seen some of my other presentations, I'm like, let's write some Python. That's not happening today. But when we talk about what we believe network infrastructure as code means, this is our take of what network infrastructure as code means. How many are you familiar with the concept of infrastructure as code? And how many of you believe that that's everything to do with configuration management and exclusively with configuration management in some way or another? Because it is. I mean, the tools that we described, Chef and Puppet and Ansible and Salt, that was their role. Their role was exclusively configuration management. And we've tried as an industry to adapt some of those tools and ideas to the networking automation space, and with mixed results. But this is how I look at network automation and starting from a design. A design is a representation of something that you can programmatically reason about. It is not a Visio diagram. It is not a Google Doc. It is something that represents your design in such a way that we can run it through we'll call it a design compiler. Again, the implementation details are not important here, just in the concepts of things. Imagine there is a design compiler. And if you're familiar with software development, a compiler will take your program and it'll tell you where the errors are. And in this way, we have a design compiler that will tell us, is our design good? Is it a valid design? And if it isn't, tell us where the design is broken from a design point of view, which I'll get into how that works. And so maybe there's this cycle of doing, oh, I've made this design, it's not right, I fix my design code, whatever. But as a result of this design, it will produce essentially the checks that we will then use to articulate against the actual network. It also generates what I would call reports. And these reports are very important because I think the gentleman asked, like, well, what if you did something before you roll out a change or build out a network? Like, how do you validate? How does a network engineer validate that the requirements of their network, whatever they need to be done, match what the automation is going to do before it does it, right? And that's the purpose of reports, and I'll show you some examples. Now, you can use the design to generate configs. I mean, it's definitely something that's possible. You can't go the other way around. You cannot reverse engineer a set of configs off a series of boxes and know what was in the mind of the network engineer when those configurations were built. You can't reverse engineer. You can only kind of go one way. At least that's what I believe. So what is a design? A design is the composition of a set of devices and their roles in some kind of network, something that's networked together, combined with a composition of what I'm going to just call design services. Design services, I'm going to get into a little bit more detail. They represent the building blocks, the levels of abstraction in a service that you can just kind of glue together in whatever kind of designs that you want. And then the business logic that kind of glues those things together. So every network is going to have a topology service. I mean, because it's a set of devices, it validates IP addresses, lags, transceivers, interfaces, cabling, like every network, we want to do that. Some designs have VLANs, maybe some others don't, but most of them do. Some of them have precision time protocol, some of them don't. But the idea is the level of abstraction, the building block, is this concept of a design service. So if you're kind of trying to understand the quality of your network, you would kind of, in your mind, maybe have this matrix. These are all my devices in my network. These are all the services in my network. And the blue represents the surface area of what you're testing against, right? And when we run a check, maybe the results look like this. Something passes, something fails, and when something fails, we can kind of dig into it, right? So we know that this network is not valid. But if you look at it horizontally, we can say this device is operating correctly, right? Maybe not all the devices are, but this one is okay, so we don't have to focus on it, right? What's really hard, this is a really hard problem, is this service operating correctly? Is multicast okay? Is precision time protocol okay? And that's really hard because you have to basically gather data and relate it amongst multiple devices. Some of those devices may be different operating systems and such. So trying to kind of make sense of a distributed system and the data that you get from it to vertically understand the health of a service is a really hard problem to try to solve. But it's really important because if you're broadcast engineering and you want to know, like, hey, is precision time protocol okay because maybe our video is looking a little weird, the network engineers, they don't want to spend 30 minutes trying to run all the commands and suss through all the data. They can run this thing and say, PTP is working. So it's not PTP. And of course, if everything's green, then the network is operating as you would expect it. So before I go into how we do the checks and how we do the validation, I want to talk about the design reports because I have often found like getting the requirements out of the stakeholders of the network to the network engineers is, for us, it's, we have a lot of stakeholders to the network. So trying to understand what are their requirements and how they change and what do we need to do the network. The reports are meant so that we can ensure that what we're going to build or design or validate is what the stakeholders want. And so this isn't, again, about config generation. It's about, are things cabled the way we expect them? Could we use that cabling map so that the smart hands, when they go on site, know what they're supposed to plug in? Or it could be used to generate a bill of material so that we can order the right transceivers or the right parts. It's important for us to know like what every port is being used for and how it relates to the service. So these reports do that. So this is an example, for example, of our cabling report. And it tells you this device on this interface for this purpose, and we use this concept of an interface profile, which kind of wraps up what is the purpose of this interface and its physical connectivity to each other. And what's important about this is if there was something wrong in the design, like let's say part of our design said it's going to be 10 gig long reach optics, and the other side of that connection in the design was wrong and it said like 10 gig short reach optics, they would highlight in the design and say, hey, your design is broken, you need to fix that. The interface mechanism is, really important to us because we operate, again, this kind of really complex edge with all these weird requirements. And so we really need to understand how every interface is being used and what its role is, and not only the physical transceiver, but the actual speed. And so these are, physical level problems. But what I found is the vast majority of problems that we experience are kind of physical level problems, some of which are, physical failures like transceiver failures and such. But understanding the physical layer is super important. And the profile gives us essentially the composition of the services that are being used, which is how we then generate the series of checks against what we need to measure on the device. So when I look at quote-unquote source of truth systems like a NetBox or something, I wish there was this concept of an interface profile because it really allows us to understand the design and the use of those interfaces beyond just a description. Because if you walk into a new network and you see a description, you're like, well, what does that really mean? So this is super helpful for us. How many of you are familiar with precision time protocol? Awesome, awesome, awesome. Precision time protocol is a really great way to showcase the reason why a system like this is so important. In precision time protocol, there's a device that gives you your origin clock. They call that the grandmaster. And where it is physically located on your network really drives the convergence of that protocol, right? Because there's interfaces that come up as master and slave, and there's all sorts of mechanics. The configuration is very minimal, but the operational state is very important, because if PTP, again, for us, if PTP goes sideways, bad things happen. And understanding is PTP okay or not is non-trivial. So in a design, there's nowhere in the config that says, that has meaningful, that says this is the grandmaster and this is how this should be. It's like, that's just the element of the design. And if we moved the grandmaster from one part of the network to another part of the network, then the expectation of the convergence of those states also changes. I don't have a really pretty picture of how that graph looks like, but if you're familiar with PTP, this is a problem. So when we show this report to our broadcast engineers, they're like, yep, that's the device, that's where it's supposed to be. These are, they kind of understand this. We're going to get into an example report of this data later in the slide. All right. I know these are like crazy concepts, so another audience participation thing is like, if you're like, I don't get it, raise your hand, because that will help me like gauge like, am I being a crazy person? All right, let's get into the design services. These are the reusable building blocks, so that when we have to build new networks or add services to networks, this is a way that we can make those changes in the design really fast and with a high degree of reliability in our engineering efforts. So what is a design service? It is vendor agnostic. It's systems agnostic. Like topology is an idea, but it's not specific to an Arista or a Cisco. It's a concept of an idea that gives us a service-oriented building blocks. But what is inside of, think of it, inside of a service, design service, is validation rules. Like if I were to design a PTP in my network, is that design valid? Am I trying to connect two interfaces that are designated master to one another? That's not valid. Or if I'm trying to do BGP peering, and in our case, point to point, are the IP addresses on the same subnet? That's a design kind of criteria. So as a network engineer building services, you know all the design criteria in your head, right? And this is a way to encapsulate that idea. The design services also have this concept of build automations, meaning when I'm trying to use a feature, and I'm going to show you an example, like with VLANs, how we can achieve a design without having to go into 17 different YAML files and putting the same VLAN in 12 different places. Like that just drives me bonkers with people showing me how they do this with like a system like Ansible. A design service is what encapsulates the types of checks that we're doing. And these design services can be general purpose, like topology or VLANs or multicast, but they can also be very specific to your enterprise. And this is super important if you have enterprise requirements that are super wonky, right? Open config and Yang models or whatnot just don't work for us because they don't address the needs that we have. So, what do you do? So here's a kind of an idea of what I mean by a design service automation. If I'm building a network that has VLANs, there's a mechanism that we can say this interface uses all the VLANs that has been defined on all the edge ports, right? And that's what all means here. So if you're on switch 1 and the edge ports use A, B, and C, then all is a trunk port and it uses A, B, and C, great, right? That's all. And peer means based on the topological design, I know what my peer is using, so therefore I am going to use the same VLAN definitions that my peer uses, right? So if you look at switch 3, if we were to add another interface that uses a new VLAN F, then F is added to all. And then on the aggregation switch, that peer says, oh, I'm supposed to use F. Automatically, I'm not changing 12 different YAML files. And then all on the aggregation switch also gets F. And then the router has a peering relationship in the design, and it gets F. This is just an example of what I mean by build automation. The idea is if I'm making a change to the design, I can make it as simple and direct as possible without having to replicate that information across all the other aspects of the design, because the design is something that I can programmatically reason about. All right, we're doing well on time. Other design validation ideas are ensuring that when we say this interface is connected somewhere, where is it connected to, and is it connected in the right place? We want to make sure that the cables are of the form of the correct form and speed, and we want to ensure that that transceivers are used properly. We want to make sure that we don't have extra transceivers out there. Like if transceivers are 10 grand a pop, we don't want to just have them out there not being used. Like we need to know that. And we want to make sure that interfaces, for example, the ones that are supposed to be down are down, or the ones that are supposed to be up are up. Another example is the point-to-point are in the same subnet. These are design validation ideas. That's what I mean by that. All right. Now I'm going to talk about like how validation actually works. So this is another very important concept of how we translate from the design service to actually measuring the state of the network and comparing it. So I'll just use the word like a validation, or I like to use the word check. But really, when we're validating the network, there's the model of what a check means, right? We're checking something. If we're checking, for example, the cabling, the parameter of that check is the device in the interface, and the expected fields are what is the remote host and what is its expected interface. That's the idea of the check. The measurement is what we're actually pulling from the network, from a device, from a controller. It doesn't really matter where or how we get the measurement, but the measurement is what the actual state of the network is. And then we compare those two results, right? And from that, we get kind of a state of that check. Did it pass? Did it fail? Was this just something we're trying to gather informationally? We gather data and logs about it so that if there is something wrong here, we have as much context about that check as possible. And I want to retouch on this. Design services, they define their check collections. So those are kind of units of building blocks. And when a network automation engineer changes the design, the composition of those checks automatically change. This is such an important concept because when you really think about it, if somebody manually checked all the things about a network to validate its operational correctness, it's thousands upon thousands of checks. Like people just don't do this like manually. Right? And the reason why this is such a hard problem is because when the design changes, they have like, well, okay, well, what am I supposed to check? What are the things that I need to do? Do I go back and regression test all of the things? Right? That's really hard. If you're making 2 changes on your network, you go back and change or check the 30, or 50 or 1,000 checks that you would have normally done during your first turn up? No, you probably don't. But you could, because that's what this kind of idea allows you to do. So when we gather the data off the devices, I'll use this concept like a measurement engine. Again, at the end of the day, it's code that's pulling data off the devices. Is it important how we do that? Is it if it's netconf or restconf or openconfig even or JSON or none of that is specific to this idea. That's a implementation detail. You might have specific device drivers, quote, device drivers. In my head, that's what I think about for specific operating systems. You could use technology like PyATS from Cisco that does a lot of that heavy lift for you. You could use Napalm. You could even use Ansible. There's not a prescription here on how the data is gathered. What's important is the model of what we need to gather and how we're going to compare it. SusieQ is something that I've been tracking. I think that's kind of an interesting idea because they are a multi-vendor kind of collection mechanism. So, the point of this slide is that we're not locked into a decision like it must be Ansible or it must be X or Y or Z. We have choice and control. We have agility over this particular aspect. And I think a lot of people get tripped up here. Like they get really focused on the tool because that's perhaps the only way that they're looking at the problem. So if I kind of take a slice of a design, I would say, okay, in a design service, like if we looked at just VLAN, the VLAN design service, there are 2 types of checks that we do, or collections, switch ports and VLANs. And it isn't just like, is this VLAN configured? It's like, is it operationally correct? Is it the exclusive set of VLANs? Like, for example, if somebody like added a VLAN that shouldn't be there, like how would you know? Like it checks for exclusivity in lists and those types of mechanisms. And then above the line is kind of your design abstraction, and below the line is the implementation detail, whether it was done for EOS or iOS XE or some other operating system. You have these little measurement engines, I guess is the way I'd call it. Or if you were using something that accounted for all the platforms in your network, like maybe if SuzyQ worked for you, that would be just SuzyQ, right? But each of those design blocks are independently thought about, and we have the independent approach to making the choices of how we collect data. So if you think about like the topology checks, like if somebody said like, is your topology in your network good? Like is the physical layer correct? I remember sitting in an ONUG meeting like a billion years ago, and people were like, what should we try to automate? And somebody said, well, we should try to automate, like validating that the physical network is good before we try to like debug, some more complicated things. And I'm like, yeah, that's something we should do. We all understand, ports and transceivers, and like that's something we should do. So that was kind of a first easy low-hanging fruit. Validate the topology. Some of those things are pretty obvious. Some of the things might not be obvious, like if you have a link aggregation and you're using the LACP protocol, and this happened, like this is a story I could tell, is that, well, what if one side of your lag bundle said, I've got 3 links, and the other said 4 links? And like, that's a needle in a haystack problem that is hard to find. And that kind of problem, it might represent a bug or some kind of misconfiguration. But detecting those types of problems is really hard, and we want to validate those things. So when I look at the output, and this is, again, our implementation of this idea, but when we look at an interface that's failing, it tells us, hey, this interface has a field, so we're measuring multiple fields or multiple points of interest, for each of these checks. This interface 3 in this case, it's not operationally up as expected, meaning, in this case, we expect it to be true, up, but it's not. But we could also have the flip side. We could say we expect this interface not to be up, but it is up, which means somebody turned up an interface that we didn't expect in this design. So it measures many aspects of something that's important in our design. And the speed one is kind of interesting. Here we're saying, well, we expect this interface to come up at 1 gig, and it came up at 10 gig. Maybe there's something a little weird there. But then when we have a passing result, we get all green, we know exactly what has happened, it captures the results, we have a record of that detail, and we know with confidence that this aspect is working properly. All right. Sometimes all we need to do is measure the state of something. In the case of the device check, we want to make sure that the device we think we're talking to is the device we're talking to. Like, is this an Arista box or is it a Cisco box? This is supposed to be a Cisco box. It's not a Cisco box. That's a problem. But we're also gathering data, like what is the version of code that's running on it? We might want to gather the serial number. So when we make an assessment of the network, it isn't exclusively for doing validation checks, but it mostly is. But we also have the concept of pulling in a measurement, and those measurements are important because we can reason about those in a way that I'm going to show you. When we look at, again, the device view, like, is this device working? It's from the point of view of all the checks that we've gathered about that device, and are they all okay, right? Some of these things are, in case of PTP, like, are all the port states in the state that we expect them to be in? And sometimes those port states can be one of multiple states. They could be master or passive, for example. So understanding the device-oriented point of view to ensure that it thinks it's okay is super important. But then when we go on like the network-wide, in PTP world, you want to make sure that everybody is in the same PTP domain, is seeing the same grandmaster ID. Now in the design, we don't say, this is the grandmaster ID, right? Because we don't know. It's a piece of broadcasting gear or clocking gear. But we measure that, and then we look at all the devices, and we say, well, are all the values the same, for example? And the network-wide is when you have to compare information from different devices in that network in a distributed way. Some of those are fairly straightforward, like link aggregation. Some of them are really, really complicated, like multicast. And we find that when the concepts or the services are really complicated, they're more important. So we really put a lot of value into measuring those things and making sure they're correct. So I'm gonna again look at this example of PTP. This is the design, but what's the actual state of the network? We can see that the results say, I am seeing a consistent grandmaster ID. Okay, that's good. And I can see that all the interface relationships are good, meaning we don't have one saying master and the other side being master. That's invalid. We can see that some of those ports are reporting PTP saying it's disabled because we know from the other measurements that the interface is down. So we have context. This is what I mean by context. But that grandmaster ID is not being read off the port that our design tells us, which means we're not actually getting the grandmaster clocking that we believe we're supposed to get. We're probably getting it from one of the devices. And we know this because we know where it's supposed to be. And likewise, this is an example where it says, PTP is great, it works. We know exactly that everything is okay and everything is as it should be. So because when the broadcast engineering guys say, is PTP okay or is multicast okay, we want to go from, oh crap, there might be a problem to, yep, we have definitive proof that what we're measuring is exactly what it should be. So this is my last slide. When we think about network infrastructure as code, we've kind of flipped the script. Configuration automation is very important. There's no doubt. If somebody is saying the problem that we're trying to solve is humans make configuration errors, so therefore we need better configuration automation, that's an answer, right? But another approach is how can we validate the state of the network relative to the config that was supposed to be there? So rather than trying to validate the configured state, we're validating the operational state. It achieves the same goal, and I think even better, right? Because we can say, like, we know that something is misconfigured because the operational state is misaligned to the actual state of the network. So in this case, the design is code. Think of it as the design is code. It's something that you can programmatically reason about. You can check it into GitHub. You can version control it. You know who made a change to your network in the design, if you want to think about it that way. The design checks, again, are the analogy to unit test or system test that software development organizations go through. And again, if you're using software like on your phone or on your laptop, you don't care what language it was programmed in, that application. You care about your experience with that app or that piece of software. That is the operational state equivalency in networking. And that's really, really hard. Again, taking it from the point of view of when the design changes to automatically have the confidence that you'll validate the state of that network is a very hard problem to do. And this idea, this approach really encourages people to ensure that the design information about your network is kept up to date. Like, how often do you walk into a network, maybe you acquired a company or some network that you haven't seen in a while, and you're like, well, what was the design of this network? And you then go on this archaeological expedition to draw pictures and figure out, well, essentially reverse engineer based on the configs. Like, what were these guys thinking? Or y'all thinking? So this idea encourages people to always keep the design up to date, which I think is a pretty mind-blowing idea. I don't know how many of y'all keep your designs up to date because it's like, well, we drew this picture and like a month later it's out of date. Like, that doesn't happen in this approach. And I think one of the most important aspects to me as an individual who's old and is now working with the next generation of our network engineers, the young folk, right? The young folk, they want to learn network automation. They want to understand what is a best practice. They want to learn Ansible. They want to learn Python. They want to learn these things. And by driving this approach, it makes them learn these behaviors. This approach makes them learn to use tools like Get. It makes them think about the problem differently. Maybe this is the paradigm shift that we desperately need in networking. Again, I'm not going to say that, but I hope you guys think so. That's my talk. I wanted to keep a lot of time open for questions. This is my very specific view. I am very opinionated about this idea. And a lot of people think like, you're ranting like a grandpa, you're a mad scientist. So I invite you to, ask questions now or find me later. If you really want to see more details about how we do this thing and you want to see like a live demo or whatnot, I'm happy to do that, in the hall or whatnot, but please, I invite you to ask questions and challenge the ideas here. Thank you.
Ben Shapiro, Eugene School District 4J. My mind is blown, and I've had to reverse engineer every network I've touched because there's no documentation. So this idea is very encouraging to me, especially as I approach ripping out and redoing the network I currently operate. It'd be nice to version control that and keep it up to date. When we talk about network automation and orchestration, one aspect I find missing from the conversation frequently is what the human cost is in commissioning such a system and keeping it maintained. I know that for my K through 12 institution, our FTE in the technology department has not changed in 20 to 30 years. So why would I make my system more complex? What are the savings? What did it take your organization to implement and maintain the system?
Yeah, fascinating questions. The backdrop here, and there's no easy answer, by the way. The backdrop here is if you look historically at the DevOps movement, like the puppets and the chefs, it wasn't like one day Puppet came on the space and they said, hey, we're Puppet, and we've got this crazy new way of doing things, and it's awesome. And it's going to save you time and money, and it's going to transform your business's ability to deliver new services with a higher degree of quality and all the real business value there is there. Didn't happen overnight. Didn't happen in a year. Didn't happen in 5 years. Took about 10 years for them to cross the chasm, right? So it's an investment. It's almost, I don't want to say it's a generational investment, but it takes, first and foremost, leadership saying, this is something that we want to do, and no matter how long it takes, whether it's a year or 2 years or 3 years, this is a way we're going to approach it because we believe in the benefits that it'll afford us. And even today, like if you talk to the people who went through or going through the DevOps movement, they would have a similar presentation like this, and they're like, this is awesome, Puppet does this or Chef does this, and people are like, I don't get it. I'm not going to do it. It's going to add complexity. I'm going to have this new team. And some people just didn't make that transition because it wasn't important to them. They didn't see the value. And others are like, I get it. So it's not going to be overnight. As Chris said, we've been talking about modern network automation for a decade. I've dedicated the last 10 years of my life understanding all the nuances and differences of all those tools and the pros and the cons. There are no easy answers, but patience and stamina and more patience and making sure you have the leadership, to drive that. Yeah.
Yeah, thank you.
Yeah. Hi.
Doug Montgomery NIST. Somewhere in the talk you said that Yang models don't work for you. I guess you meant they're not enough for you. Have you thought about what could be done on the standardization side to better enable the kinds of things you do?
Have I thought about it? Yeah, absolutely. Absolutely. I mean, there's two challenges in that kind of line of execution. One is not all of the devices that we use support, an underlying transport and modeling technology. That's like a real problem, for us. If you're a scale-out data center that is homogeneous, maybe not. That is not your problem. That's not a problem they face. I've also, I spent 20 years in vendor world working in standards bodies in some way or another, and those types of things do take time and effort and change, and we don't have the luxury necessarily of that. When we have to deploy a new piece of AV kit, for example, or we have some bespoke reason that we need to do something in our network that just doesn't fit into that model, we don't have the luxury to try to drive that change. We kind of have to do it right now. It might not be the right answer, but it is our right now answer, and kind of that's how I have to approach all the things. There is the right now answer, and if you're using Ansible and Puppet, or I'm sorry, probably nobody's using Puppet, but if you're using Ansible or Python, and that's the right experience for you right now, there's nothing wrong with that. That's your right now, and maybe that will be the right answer, but for us, we couldn't put ourselves into that kind of constraint. I don't know if that answered your question, but maybe not. Find me afterwards. I'd love to talk to you more about it.
Hi, Alex Bortek, representing Open Traffic Generator project. So I have a positive feedback for you as well as a question, right?
Great.
So that on the feedback side, we're definitely looking into the same direction. Inside our projects, we test devices, we test systems, networks, and so forth. And you can imagine every time design, configuration, or whatever changes, the test has to change, and nobody has time to rewrite tests.
Right.
Right?
Right.
So
Right.
definitely.
Bingo. Bingo.
So yeah, I think we are definitely aligned here. The question I have is when you're saying how you define design, I saw that a list of devices is an input to the design. And I'm thinking, well, what if some devices are unnecessary or maybe something is missing? Have you given a thought about like testing for like, is this device should be here at all, or is my topology should be like it is part of, you know?
Yeah, that's a fascinating question. So we do account for that, but not through this type of mechanism because like we have another piece of software, a commercial product that kind of gives us the state of our network by, crawling the network. So we know what's out there. So from that, we can detect whether there's something out there that shouldn't be, or even when something shows up when it should be. That's how we kind of address that problem, at least today. That's kind of our right now answer for that. But it depends, because if you're using a controller, let's say that you're using, for example, a wireless controller, it's very easy for you to access that inventory programmatically to know what's there or what's missing, kind of in real time. So that's the kind of the idea of that. And taking a system like this that understands the design programmatically can then drive other systems. Like, people will talk about Netbox as a source of truth, but this system drives what goes into Netbox, which then in turn drives what our monitoring system needs to monitor and how it should monitor it. So for us, we look at this idea as kind of the missing link between configuration management problems and network observability problems, because in isolation, they don't know what's right or wrong. This is the way that drives the symmetry between those systems. And so your point is very well taken, and it's a very important aspect. It's kind of a take on the, do I have too many transceivers that shouldn't be there problem, in a way.
And also thinking that maybe this part could be automated, because if you are building this, a network which has a lot of, say, virtual network functions, right, you can scale them horizontally, right, so the number can change, but there are certain criteria of how many of them should be depending on the load, for example. So I think we could.
Yeah, thank you.
All right.
Thank you.
Thank you.
Thank you.
Okay.
Awesome.
Hi, Chris Woodfield with DriveNets. An adage I've heard a number of times when it comes to these sorts of automation exercises is, don't boil the ocean, boil a cup of tea first. I think Ben mentioned, every new network he encounters is an archaeological dig at first. When starting the journey, so to speak, of trying to apply a design-driven model to an existing network, where's the cup of tea?
Yeah.
What would be the first thing that you could recommend that
Fantastic
someone could start?
question. Yeah, this is such an important question to ask. Because again, one of these triggering conversations is, well, you have to do all the things before you get the slightest bit of benefit, right? So let's say that you have to start with a topology design service, because every network does. And then you just start there. You start mapping out, essentially, these are the devices, these are the interfaces, these are their purpose, these are how they're connected. And as you run the analysis, it'll tell you, hey, there's something wrong here, right? So I have to go fix it, which means I have to go back into my design and update it. Maybe I forgot an interface, maybe I forgot a cabling definition, whatever it is. And this is such an interesting thing, because the junior network engineers who are using this tool, it's almost like a puzzle game for them now. It's like they run the tool and they see like something's missing, and then they go back into the design and they add it, and they run it again and they see it go green, and they're like, yes, right? And there's actually kind of a really fun experience that they're having with that. And so they're mapping out the network that way. Like when I joined MLB, there was no network automation. There was complex networks everywhere. Like this idea has not been mapped out universally at MLB. Like, I mean, we're starting in small pockets and with small network ideas, the important aspects of the larger networks. So you pick and choose those battles. But the important message here is, again, this is a read-only operation, right? We're not risking like a network automation takes down the network type of event. So the junior network engineers who are learning this idea or experimenting with this idea, they can do that with confidence that they're not going to harm the network. And so that's another way to look at where do you start. Does that help?
Yeah, yes, it does. Thank you.
Yep. All right, we're still over here.
I have an online question from Matt Peacock, an automated engineer. Jeremy, do you have any examples of what you consider a design in terms of code? You talked about the design checks updating automatically when the design changes, but in my experience, checks are written by humans and never update automatically. How do you design lead to checks updating automatically?
Yeah, that is that's a 2-drink minimum question, but I'll try to answer it. In the context of a design service, if you were a network engineer and you said, well, what are all the things that I would do to check manually, the show commands, like what are all the things that I would do? What are the outputs and the elements of everything that makes sense to me so that I know quantifiably whether it's right or wrong? What are those things? Those are what goes into the algorithm that defines the definition of those checks. Like what are the parameters and what are the fields that we expect to measure? Not how we expect to measure them, but what we're supposed to measure them. And because the design is an entity that we can programmatically reason about, for example, we can look at the design as a whole and we can look at every single interface in that design and we can say, okay, on this device, what is the complete collection of all VLANs in this design, A, B, and C? So we know that if we were to say, show VLANs or whatever that command is, or tell me what VLANs are on this device, what is that list expected to be? And then we measure that list and we make sure that in some cases that it's in the exclusive list, it is that list and no other list. So when the design changes and we can programmatically reason about the structure of our design, we can automatically define the checks that go into that, we'll call it a check collection. Now, what goes into that check collection, meaning what are we actually measuring for this design service, is a collaboration between the network automation engineer and the network engineers themselves. Like the network engineers, like I am not a PTP expert, but my network engineers are, and my broadcast engineers are, so we had to have a collaborative session. We understood what was important for them to measure, what aspects needed to be validated most importantly, and that is what went into the definition of the check. How many of those checks do we do is just an analysis of the design to say this interface, but not that interface. So at a high level, I'm hoping that's answering his question. I'm not sure that it is, but I hope so.
Hi, my name is Greg Berry. Thanks for the talk. It's really interesting. I'm wondering how these changes that you've made have rolled into your NOC. Has it changed fundamentally how the NOC's monitoring the network and changed from a fault-driven kind of feed to more a status? And I'd be interested to hear what's changed there.
Yeah.
Thanks.
So for us, our network operations team is part of the network infrastructure team. So we don't have a separate over-the-wall kind of organization, but that doesn't change the answer. The answer is this is a technology that they can instantaneously go, what is the state of this site, or what is the state of this network? 30 seconds later, I have quantitatable results that give them pinpoint, good or bad, or yes or no. We have even looked at making that execution self-service to the stakeholders of the network. What if the broadcast engineers could go into Slack and go, hey, how is the Atlanta Braves today? Is there anything wrong with PTP? And it goes, here's your results. That is the next evolution of this execution, because anytime that we look at something that we could automate about the network. We look at it from the stakeholders' point of view, not the network engineer's point of view, not the network operations point of view. I mean, they all matter very much, but if we can put that technology in the hands of the stakeholders directly, it reduces the burden of operation on our network operations team dramatically, and we've proven that over the years. So that's kind of our general approach. Did that answer your question? Okay, great. Awesome, awesome. I got 1 more minute. This is awesome. I love the feedback. Does anybody want to stand up and tell me I'm crazy? All right. Thank you very much. If there are no further questions, I really appreciate your time and attention and the questions, so thank you very much.